So here's our second example for finding the intersection of two planes. So we've got our equations here, our Cartesian equations. We'll call these plane 1 and plane 2. And first thing we want to check is, are these two things parallel? So we'll get our normal vectors here. We'll get 3, negative 2, 1. And we'll get our second normal vector is 6, negative 4, 3. And we're checking to see if these two things are scalar multiples. They are not scalar multiples because, let's see, if I take my 3 and I multiply by 2, I get a 6. If I take negative 2, multiply by 2, I get negative 4. But if I do my 1 times 2, I end up with a 3. Well, I got a 3 there instead of the 2 I would expect. So this is telling us that normal 1 is not a scalar multiple of normal 2. Therefore, these two things are not parallel. So our planes definitely have a line of intersection. And so remember, what we're looking for are the parametric equations. We want an expression for x, an expression for y, and an expression for z. So we're looking for this. So our first step was to write out our system as a system of two linear equations, stacked one on top of the other, and try to eliminate one of our variables. So looking at this, what is the best thing to try to eliminate here? What did you try? Yeah, so let's eliminate x. So we'll say step 1, eliminate x. So we'll take, to eliminate x, we're going to multiply this one by 2, and then we are going to subtract. So we get 6x minus, not 2y anymore, but 4y, plus 2z is going to equal 8. And we keep the second one the same, 6x minus 4y plus 3z equals 7. Okay. And we are going to subtract our two equations here. So we do this, and we get x's go away, y's go away, z equals 1. Which is a little bit different than what we had before. Sorry. Negative 1. What have I done to get 1? Thank you. Negative z equals 1. Z equals negative 1. Okay. Again, so this is a little bit different than what we had before, where before our next step was to take what we got from this elimination and rearrange it to solve for one of our variables. This is good, though. We already have this solved for one of our variables. It's already solved for z. So we can check z off our list here. And we have our expression for z. So we can jump on to step 3, because step 2 here is already done. Step 3 was, well, eliminate that variable that we just solved for. So we'll come back to our system here, and we want to eliminate z from those two equations. So let's see. To eliminate z, we're going to have to take the first one, plane 1, plane 2, and we'll take the first plane and multiply it by 3. So I'll just do times 3. And that'll get us 9x minus 6y plus 3z equals 12. And we'll keep plane 2 the same. 6x minus 4y plus 3z equals 7. And we are going to subtract these two equations. So when we subtract them, we get 3x minus 2y equals 5. Okay? We want to rearrange this to get one of our other expressions. So we have a choice here. In the last example, because at step 2 we had an expression for x in terms of one of the other variables, we wanted to solve for the same get an expression for one of our other variables in terms of that sort of same variable. Now we don't know which way to go. So in truth, it doesn't matter. We can solve for whatever we want here. So I'm going to solve this thing for x, I think. So this is step 3. Oh, sorry, step 4. Let's that wasn't step 4. We'll just say solve for x. Okay. So let's rearrange this here. We get 3x equals 5 plus 2y. Okay. Or x equals 5 over 3 plus 2 over 3 times y. And that is our x equation. So we've got an equation for z. We've got an equation for x. Step 4, we've got y left. Choose y equals to t. And then we can go straight to our parametric equations. X is going to be 5/3 plus 2/3 times t. Y just equals t. And z just equals -1. And those are our parametric equations. So if we wanted to, we could turn this into a vector equation. We've got 5/3. We have no constant there for y, so a 0. We've got a -1 as our constant for z. So that's going to be our point that's on the line, plus t times, let's see, we've got a 2/3 as our x component. So let's put 2/3 in there. We've got a 1 for our y component, and we have nothing for our z component in terms of t. So the vector equation, 5/3, 0, -1, plus t times 2/3, 1, and 0. And we're done.